All right, starting chapter 6. And in chapter 6, we're going to start with some triangles and the law of sines. Law of sines, law of cosines, we had touched on real briefly in geometry, but now we're going to go a little more in depth. And we use these for oblique triangles, any triangle without a right angle. We can use them with a right triangle, but it's more work, so we go to the simple a squared, b squared, c squared, Pythagorean theorem, SOHCAHTOA, and such like that when we work with a right triangle. But this oblique triangles, we can use the law of sines or cosines to still find missing pieces. So we're going to work on solving a triangle. And remember, to solve, right, means to find all the missing pieces and all the missing sides, right? So we find all sides and angles. Okay, so a couple things here as we talk about the law of sines and cosines. One is I need to make sure we understand how to label a triangle. So we have a triangle, 3 angles. It is commonly called angle A, angle B, and angle C, and we tend to capitalize those angles, okay? Then side A, or little a, I'll call it, always comes from across from angle A is little side A. Side B comes across from angle B, and side C is across from angle C. Okay, so it's important to understand that when we go to these formulas, when we go to different rules here, that when they talk about angles A, B, and C, or sides A, B, and C, the relationship between the angle and its same letter is across from each other. So it's important to know that. Okay, so there's different relationships within a triangle. You need to be given at least 3 pieces of information from the triangle to be able to solve the triangle. One of those pieces must be a side. You cannot solve a triangle if you don't know how big it is, so at least one of the sides have to be given. So there's different combinations of information we can be given if one of them has to be a side. We can have an angle, then a side and an angle, so the sides between the 2 angles. We can have an angle, and the side outside of the 2 angles. We can have a side and a side with the angle that's not between the angles, the sides. We can have side, angle, side, and we can have side, side, side. Now, of these, I'm going to just draw a line right through the middle here, because these 2 on the top we're going to use today with law of sines. Okay? And then the bottom 2 with side, angle, side, and side, 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 we're going to have to start at least with law of cosines. And we'll look more at those tomorrow. Okay? So we're looking at law of sines, and law of sines is a great thing if we have angle, side, angle, 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 side, or side, side, angle. And yes, I know I never write that in geometry, and I wrote it backwards here, and I'm going to keep it backwards, and I'm going to say it side, side, angle every time. And I do want to stress to you, when we learned triangle relationships in geometry, it was 2 triangles, and both of them share this. This is just information given and the relationship with the information given in one triangle that we're kind of sorting it out this way. Okay, so in this big box, you see the law of sines. Sine of big angle A over little a equals sine of big angle B over little b equals sine of big angle C over little c. It's a proportion, a ratio, right? 2 equal signs there, which means we can really only use 2 at once. You can't use all 3 at once. You choose which set of them you need. The key is you can only be missing 1 piece of information out of the 4 pieces, or else it doesn't work. Okay. I need to say this right now because this is important, and we'll see it in our notes today too. Law of sines will only solve for acute angles. It helps if I can spell. I'm going to look at that later and say, I don't even know what that is. Let me do capitals. Acute angles, okay? So important to know that you're only going to get acute angles when you use this law of sines. So we always have to keep in the back of our mind this idea of, well, wait, could it be obtuse? Because if it's obtuse, our calculator will never give us an obtuse angle when we use law of sines, okay? One of the other key things we need to make sure we do, degree mode, okay? I know I had to switch mine because last chapter we were doing all that radian work, and so my calculator was in radian mode. Make sure you switch it back to degree mode while we're using law of sines. So we're just going to start working with these. Given some information, can we use the law of sines to solve the triangle? And remember, solving the triangle means find all the missing pieces. So on A here, just to help myself out, I'm going to draw a picture, okay? It doesn't have to be to scale, right? A, B, and C are my angles. Let's see, they tell me angle B is 64. They tell me angle C is 38. And they tell me little side A is 8. Okay, that's what they give me. I want to find the rest. Okay, I'm going to start with my angle. If they give me two angles, it's super easy to get the third angle because I know all angles add up to 180. So for angle A, I know I'm going to do 180 minus my 64 plus my 38. Okay, remember, I'm more or less writing all this out. So if somebody's absent, they know where I'm getting all this, right? 180 minus my 64 plus my 38, 78. So angle A is 78 degrees. Okay, I've got all my angles done. I have one side. I need to find the other two sides. I am not allowed to use Pythagorean theorem or SOHCAHTOA if I don't have a right triangle. So don't go back to those where we know this is where we have to use our new law, which is law of sines. Okay, which one of the law of sines do I want to use? Because I need two of the three. Well, what I always check for first is which one do I have both, an angle and its side, because I need one of them to be completely filled out. Well, it looks like I have A and A, so I'm going to use sine A over A since I know both of them. And I might as well solve for B because that's the next one in line, so I'm going to use sine B over B. But you could have started with C and there's no problem with that. All right, so for angle A, I'm going to plug in my 78 degrees I already solved for. And side A across from it is 8. For angle B, I know I'm plugging in 64 degrees. And side B is what I don't know, so I'm going to leave that. Okay, solving for B, it's in a denominator. Can I ever solve for a variable when it's in a denominator? No. So I got to do a little cross multiplying. So I get B times the sine of 78 equals 8 times the sine of 64. All right, and I want B by itself. So I'm going to divide by the sine of 78. I like to set up all my problem and move everything first and get the calculator out at the very end. It keeps everything more accurate. I don't have to worry about rounding decimals or anything like that. All right, so I'm ready to hit this on my calculator. Make sure that your entire denominator is divided by your entire numerator is divided by your entire denominator. If you need to, use parentheses. Make sure you're in degree mode. So I have 8 times the sine of 64 divided by the sine of 78. That did not go where I wanted. 8 times the sine of 64. I think I forgot a parenthesis. Divided by the sine of 78. And I should get about 7.4 maybe. Okay, so down here, B is about 7.4. Okay, I'm ready for C. Once again, even though I know two sides of my triangle, I can't use Pythagorean theorem because that is only used on a right triangle. So I have to go back to my law of sines again, okay? So on this time, I'm going to stick with sine A over A. So in case I made a mistake on B, I'm not using it in my work. Now, that doesn't mean you always can avoid the numbers you solve for, but when you can, I do. This time I'm doing sine C over C. So in for A, once again, I'm plugging in 78 degrees. For little a, I'm plugging in 8. For big angle C, I know it is 38. And I'm looking for little c. So once again, I do the cross multiply. I get C times the sine of 78 equals 8 times the sine of 38. And I divide. So C is going to be 8 times the sine of 38 and divided by the sine of 78. Again, be careful on your calculator. See if I can get it the first time out this time. Got about 5.0 maybe. All right. And I've solved my triangle because I have all my angles and all my sides. Okay. I drew my triangle not because it's to scale or anything like that, but more because I always like to check my answers to see if they make sense. And that is really one of these things that after a while, when you get all these numbers, it's hard to know. You might not be able to quickly check and see if they're right, but at least do they make sense? So I go to my biggest angle. My biggest angle is 78. Is it across from the largest side? 8 was the largest side, 78 was the largest angle. That's good. My smallest angle was 38. Is it across from my smallest side? 38 and 5? Yes, they are, which leaves my middle and my middle. So at least my answers make sense. So I'm good so far with that my answers make sense, and I can trust that I did what I needed to correctly. Okay? So that one was an example of an angle, side angle. Worked fine, not a problem. Okay. By the way, angle, angle, side work similar to the same thing because either one of them, if you're given two angles, you can easily solve for the other angle, and then you have an angle and a side that go together, and you can finish solving it. Okay, but let's look at the side angle. Okay, number one of the things we have to realize with the side angle is you're given two sides in an angle, but that does not even guarantee you have a triangle. Okay, so there's four different, I don't know if I want to say four, it is four different scenarios we can have and different triangles we could end up with, okay? So one thing we have to know is, okay, remember this, we're given two sides and then an angle. So I give two sides and then the angle. Notice that one of the angles and sides have to go together. So if I'm given angle A, I get side A as well, okay? And for our sake, we're always going to call them A and A because it's going to be easier to go through the rules this way. Okay, so I have these lengths, and the question is depending on how the sides are arranged, am I able to actually make a triangle? So every triangle needs to have a height. So there's some things that we get this formula of H equals B sine A, which, by the way, once again, for Chapter 6, you have a formula sheet. If you look at your formula sheet for Chapter 6, you will even see this little box on there so that you don't have to memorize this, but you have to know how to use it, okay? So on all of these, you'll notice that they each have the height equals B times the sine of A, okay? That's a formula that, given the relationship with what you're given, if you take the angle, the sine of the angle, times the side that's not across from it, it will tell you what the height of your triangle would be for that triangle, okay? So here's some scenarios coming off of that height. If your side across from your angle that you know, if A is bigger than H, so your side is longer than the height, and your side across from the angle is also bigger than the other side, you get a triangle. Straightforward, one triangle, okay? If your A equals your H, and what you end up having is a right triangle because your height and your A are the same thing, they're at 90 degrees there to the other side, you get a right triangle, okay? We do have this scenario, though, that your A might be smaller than your H. And if that's the case, you don't even have a triangle because your A is not long enough to go down and hit your other side of your triangle. You don't even get a triangle. And then we have the case where, and this is what's important, A is going to be bigger than your height, which is good, just like we did from the first one, but A is smaller than your other side. You can actually get two different triangles. Your A might come in and form this triangle, or your A might go out. So you actually get two different triangles. And if that's the case, you have to find all the measures for the two different triangles. Okay. So we have some decisions to make. We have some rules we have to follow. We have to decide, am I solving for one triangle, two triangles, no triangles at all? What am I trying for? And with that, it'll help me know what kind of triangle, all the information that I need to solve my triangle. Okay, so let's go ahead and try this first one on the bottom here. Determine whether the given measurements produce one triangle, two triangles, no triangle at all. Solve each triangle the results. Okay, so it doesn't matter. Right away I see A, B, and angle B. Okay, I'm going to do a switch and make this angle A, make this side A, and make this B. Okay, and the reason I do that is so it fits my rule. I want an angle A with a side A. So since they gave me angle B with side B, I need to change them to A, and then my B can be my 5. Okay, so the angle and the side that go together, I'm always going to call the A, and the other one can be the B. So the first thing I need to do is figure out HB sine A. Okay, so my new B is 5. Sine is angle. I don't know why I wrote that little because my angle should always be a capital. And my A is 27. All right, make sure your calculator's in degree mode. We're going to do 5 times the sine of angle 27. And I get about 2.5 2.27. Oh my goodness, something tells me I should stop doing these notes today. 2.27, okay. So I need to check. My A is 2. So that means my A of 2 and my H of 2.27, A is smaller. If A is smaller than H, I am in this scenario right here, and I get no triangle. And I'm done. I can't form a triangle. I can't find angles and sides that will match that scenario. So I'm done. Okay? All right, let's turn the page and let's see what we get with our next one. If only we could be so lucky that they're all that way, right? No, I'm kidding. All right. Oh, they did it to us again. So I need to switch this. So I'm going to call my A 27. This isn't the same problem, is it? Oh, no, my B is different this time. Or my A, right? Because I'm switching this to A is 2.27. And my B this time is 5. So I'm just switching these up, right? All right. Almost the same thing, just a slight difference. Okay, so once again, I'm going to do my height, which is going to be B times the sine of A. So I'm going to do, my B was 5, my angle is 27. I run that through my calculator. It might still be in my calculator, and I get 2.27. Which, my A was 2.27, my H is 2.27, and they are equal. Well, if that's the case, what kind of triangle do I have? A right triangle, right? So I have a right triangle. I'm going to just draw my right triangle right now. So if my A was 27, my little a is 2.27, which is also my height, right? And my B is 5. I guess I don't know which side my B is on, do I? Okay, so let's figure it out right now. I'm going to go ahead and do sine A over A because I have A and A, and I'm going to figure out my angle B over my B, okay? Do I know my... Actually, you know what I can do right now? 90 minus 27, right? I don't need to solve for this. 90 minus 27 is 63. Oh, I know, and I guess this is one thing too I need to make sure we know. My A is 27, my little a is 2.27, my B is 5, I'm solving for my angle B, okay? I'm going to solve. If it's 90, it's 90, right? Because I'm not sure which one's which. So I cross multiply. I get 5 times sine of 27 equals 2.27 sine of B. I'm trying to solve for B, so divide by 2.27. And I need this sine off of the B, so I'm going to actually take the inverse sine over here, okay? And run that through my calculator. Okay, so inverse sine of 5 times the sine of 27. Make sure you use plenty of parentheses here, guys. And divide by 2.27. All right, that's my 89.6, which is 90 degrees. So that tells me my B is the 90, which puts my C over here. So B's here, 5's across from it. And I'm left with one more side, right? I don't need to really solve for C because I could do my subtraction and know that C is 63. I'm going to be honest, it's a right triangle. I'm going to A squared, B squared, C squared, that one. My C is 5. Looks like my A is 2.27. I'm finding my C right now, even though it seems funny that my C is not my hypotenuse, but make sure it's squared. Okay, so I'm going to take 5 squared, which is 25, and I'm going to subtract 2.27 squared. I'm going to take the square root of that nice number. and I get about 4.5 maybe. Okay, once again, is the longest across from the longest, 90, and 5 is my longest side. Smallest angle is 27, across from that's 2.27. All my numbers are making sense, so I'm good to go. All right, let's try another one. And I'm assuming maybe we'll have a different pattern here, okay? Once again, I'm going to call this A, I'm going to call this A, and I'm going to call this B, so that we match our rule. All right, so I'm going to come up here and figure out my height. H equals B sine A, right? So B is going to be 6.3 times the sine of my angle, which is 138.1. There's an obtuse angle. No, I'm not going to get a right triangle, right? 6.3 sine of 138.1, and I get 4.2. So H here is 4.2. That's the height. So my A is definitely bigger than my H. So if A is bigger than H, and I need to state A was bigger than B, I get one triangle, right? So that's all I can get is one triangle. I'm going to try to find out what I know. Okay, A. I know I don't draw things to scale, but I could try to do a little bit, right? So A there at 138. Little a is 15.6. I don't know angle B. I don't know angle C, but side B is 6.3. All right. It really would help if I had more room, I think. Okay, we're solving. Which one do I know both of? A and A right now. So I'm going to do sine of A over A, and because I have a side B, I'm going to solve for angle B. All right, so I plug in my angle A of 138.1 over side A, which is 15.6. My angle B, I don't know, over side B, which is 6.3. Okay, if you are good with me doing all this math at once, I'm going to tell you that angle B is going to be the sine inverse of 6.3 sine 138.1. Make this legible. All over 15.6. Okay, so I'm going to run that through my calculator. Again, be careful on your parentheses so that everything's included there. 6.3 sine. And I get an angle B of about 15.6. Remember, they're going to be small because I already have that large acute obtuse angle, right? So B up here is 15.6. Okay. That means I can subtract to find angle C, right? So angle C is going to be 180 minus my 138.1 and my 15.6. So I'm getting about 26.3 for that angle. Okay. And I can't fit it in my drawing. Okay, and now I need to find side C. I can't use Pythagorean theorem. It's not a right triangle, so I need to set up a law of sines. I'm going to do sine A over A and sine C over C. So I have 138.1 over A, which was 15.6, equals the sine of, what did I just get, 26.3, all over my C. Okay, so when I solve for C, it's going to be 15.6 sine of 26.3. Okay, I want to be able to read this later, so I am going to write sideways, okay? So it's 15.6 sine of 26.3, and I'm going to divide by the sine of 138.1. Okay, run that through your calculator. 15.6 sine of 26.3 divided by the sine of 138.1. I get C is about 10.3. Okay. So I have an angle C, I have a side C, I have an angle B, and I started with the 3 from above. Okay, one triangle because my A was larger than my H and my A was larger than my B. All right, bottom of the page to do this next one. More room, right? We hope. I have my A and my B. They were nice enough to give them to me straight up. Okay. I need to solve first for my H. My H is going to be my B, which is 4, times the sine of 34 degrees. Okay. So I do 4 times the sine of 34. And I get an H, which is 2.2. All right. So my A is bigger than my H, which is good, but my A is smaller than my B. Because of that, I have 2 scenarios. Okay? So this is what we're going to do with this 2 scenarios. I'm going to start out with my, what I'm going to start out with is my A over here is 34 degrees. I struggle to draw these. Okay, this is what I'm going to start out with. This is going to be 34 degrees. My A over here is 3. Okay, I'm going to find my B, and my side B is 4. And then I'm going to find my C. Okay. Sine of A over A, and I'm going to go with sine of B over B because I know at least the side B. So I have the sine of 34 over 3 equals the sine of B over 4. Okay, so quick reminder, that's going to be 4 times the sine of 34. Let me give myself just a little more room. I'm going to end up taking the sine inverse of 4 times the sine of 34 all over 3 to find my B. Okay, so I run this through my calculator. Inverse sine 4 sine of 34 divided by 3, and B equals 48.2. Okay, I'm going to highlight that a little bit because I'm choosing, do you remember that rule I gave you at the beginning that my calculator will only give me acute angles? So my calculator gave me 48.2. However, just keep in mind, maybe it's not 48.2 because it could be the obtuse angle. But right now, in this scenario, we're going with the acute angle, okay? So if that's the case, for my angle C, I'm going to do 180 minus my 2 angles that I already know, which were 34 and 48.2. Okay, so if I subtract those, it's going to be 97.8. So I get an obtuse angle, but this time it's my C, right? So my C this time is 97 point, is that what I said? 97.8. Okay. So I have one more thing to find, which is my little c. So I'm going to do sine A over A again, sine C over C again. And this time my sine of A is 34 over my side of 3 equals my sine of my 97.8 because that's the obtuse angle. And then I'm looking for little c. So c is going to be 3 times the sine 97.8 divided by the sine of 34. If I am losing anybody on that algebra, please contact me and let me know. 3 times the sine of 97.8 divided by the sine of 34, and I get a C of about, I lost it again, 3 sine of 97.8. I think when I hit my division bar, it doesn't get it all the time. 5.3. Okay, so this is one scenario, okay? I can't even fit all my things in there, but my B is acute. However, I could have taken this triangle, and my B could be obtuse, okay? So I could still have this 34 here. My little a over here could still be 3, but maybe this B was not 48.2. So how do I know if it's not 48.2? Okay, So it's kind of like your reference angle and such. You just do, instead of, since that all my calculator will give me is a 48.2, that's my reference angle, I can do 180 minus that 48.2 to get its obtuse angle, right? So 180 minus 48.2 at 131.8. So instead, B this time can be 131.8, okay? So I use this same setup from over here, okay? I do all this same work, but my calculator can only give me the acute, and possibly it is the obtuse, so this time I just change it to the obtuse, okay? So I get this one is 131.8. My B was still 4, and this time, so C is going to be 180 minus my 34 and my 131.8. Can't have possibly much left, do I? Minus 34. 14.2. A very small angle for angle C. Which probably means my side C will also be extremely small, because now it's going to be smaller. I mean, 4 is my largest, so it's going to be smaller than 3, right? So sine, I'm going to do A over A equals sine C over C. My A is 34 degrees. My little a was 3. My angle of C is 14.2. I know I was going to get that morning, but I'm trying to get these done. Okay, so C is going to be 3 times the sine of 14.2 divided by the sine of 34. Divide that out. And I get 1.3 for my C. Much smaller than the rest, which it should be, right? And I get that. So 2 scenarios, one where you use the acute angle that the calculator gives you, one where you have to manually take your acute angle and switch it to the obtuse angle, and then solve for both scenarios, okay? You only have to do that when A is bigger than H and A is smaller than B, but you need to know that that's a possibility, okay? All right, one more page of notes. We're going to hope we can do this before my battery runs out. All right, for F, I'm solving for H. That's what I'm doing, okay? So I have a right triangle, but I don't know anything on that right triangle. So that's kind of hard to solve for H if all I know is the 29 degrees. You must know at least one side of a triangle to be able to solve for it, okay? However, I have this extension on my triangle that I do know at 25 degrees, and I do know a 238, okay? And so if I can, I'm really not going to draw that triangle because it's so narrow that I can't get in there, but if this is 25, and this is 238, don't forget over here, it's on the supplement of that 29, so 180 minus that 29, I do get an angle of 151 right there. And that's important because now I have a triangle with 3 pieces of information, okay? So that's my 180 minus my 29. So I'm going to use that to solve for this missing piece over here. Or if you think about it as A, B, C as they labeled, I'm looking for A if I know C already. Now the question is, do I know angle C? Yes. So for angle C, I'm going to do 180 minus my 25 and plus the 151. That gives me an angle of 4. Wow, we thought our angle was small earlier. All right, we're going to use a little sine of, let's see, I have C and C, so I'm going to do C and C, and I'm looking for A, so I'm going to do A and A. So sine of 4 degrees over my 238. By the way, if my small side is 238, can you imagine what my large side's going to be here? It's not even the largest, right? We're not finding that B. Sine of 25 over A. So A is going to be 238 sine of 25 divided by the sine of 4. Okay, don't forget that's not our final answer, but that's what we're finding right now. 238 sine of 25 divided by the sine of 4. I have 1,441.9. Okay, that is this side right here. 1,441.9. Okay, now I can use a little SOHCAHTOA, right, because I do have a right angle. If I want to find this opposite and I know the hypotenuse, I can use a little SO work. So the sine of 29 degrees equals my opposite, which is h, over my hypotenuse, which is 1,441.9. And I'm going to run that through my calculator, and I'm going to cheat because that 1,441.9 is already in my calculator, so I'm just going to multiply it times the sine of 29, and I get 699.0 for my h. Okay? So, right triangles, you can SOHCAHTOA, but if they're not a right triangle, we're looking for that law of sines today. Okay. Last set of problems is finding the area of an oblique triangle. So we've used for years that area equation, area equals 1/2 base times height, which is perfect when your base and height are perpendicular. If they're not, we can still find the area using this equation. And just so you know, there's 3 equations here. Okay? Think about your triangle ABC, your little a, your little b, your little c. Okay? And notice that on each of these, either one can be used. So in the first one, it's 1/2 b times c times sine of a. Do you notice how I see a, b, and c in there? A is the angle, b and c are the sides. Or maybe I know sides a and b and angle c. So 1/2 a times b times sine of c. Notice a, b, and c in there. C is the angle, a and b are the sides. Or I can use 1/2 a times c times sine of b. Notice again, I see a, b, and c there, but b is the angle and a and c are the sides. Any one of those is fine, so you use the one with the information that you have. So my first triangle. Organizing my information. I know angle C is 13.7. I know side A is 12.9. I know side B is 6.4. Oh, look, I have an A, B, and C. By the way, what that forms is a side angle side. When you know that, you have enough to find the area. So I'm going to choose my 1/2 that uses side A, side B, and angle C. I see my ABC right there, and I'm ready to go. Okay? 1/2. A is 12.9, B is 6.4, and angle C is 13.7. This is a calculator problem. Go ahead and plug and chug. I put in 0.5 times 12.9 times 6.4 times the sine of 13.7, and I have an area of about 9.8. And I don't know my units, so I'm just going to put units squared. Okay? Straightforward there. When given the information, the right one. So I look at H, I have angle A, angle B, and I have C. Remember, I need 2 sides and an angle to get this formula to work. So I think about the triangle I have. I'm trying to give myself room to write this. A is 42.3, B is 62.1, little c is 14.7. Okay, so right away I'm going to find angle C. So 180 minus my 42.3 and 62.1. And angle C is going to be 75.6. Okay, I need one more side to be able to use this area equation. It doesn't matter which side, I just need to solve for one. Because I'm in the habit, I definitely know I have C and C. Remember, you can't use Pythagorean theorem because it's not a right triangle that we know of. I'm going to go for A and side A. So sine of 75.6 over side 14.7 equals angle 42.3 over side A, which I don't know. So A is going to be 14.7 times the sine of 42.3, all divided by the sine of 75.6. Run that through my calculator. And I get 10.2. All right. Now, why did I find that? So that I could find the area. I have an A and a C for my sides, okay? And I don't think I have any more room. Oh, I do. Good thing for me. Not much battery, but I have room. Okay, So my area, because I have sides A and C, I need to use sine of angle B. Remember, I use A, B, and C each once. And my A is going to be my, what I just solved for, 10.2. My C is that 14.7 times sine of the angle, which was B, is 62.1. If you had found side, I don't know, C or B, you would use a different, right? But those are the ones I have. So 0.5 times 10.2 times 14.7 times the sine of 62.1 is 66.2. All right. I'll round it to 3. And there's my area. So using the law of sines, I can find that missing side, and then I can use this area formula. All right, try them. Page 652, 3 through 60 by 3s, and let me know if you have any questions. And for the record, I still have 6% battery left. Thanks.